Greetings everyone and welcome back to my channel. This is July the IT guy and I'm back here with another Cisco Packet Tracer Lab. We are on lab 4.3.8 for configuring layer 3 switching and inter VLAN routing. Alright, so let's go ahead and take a look at our addressing table. We have an MLS. What is an MLS? It is a multi-layer switch. What does that mean? It means it's able to operate on a layer 2 switch for Ethernet MAC switching and also at layer 3 for IP routing. We see that we have VLAN 10, VLAN 20, VLAN 30, VLAN 99, and also an interface here of gigabit Ethernet 0/2. We see we have 6 end devices: PC0, PC1, PC2, PC3, PC4, and PC5. And we have 3 switches, naming conventions S1, S2, and S3 on VLAN 99. And we are also provided with IPv4 addresses along with IPv6 addresses and their prefixes. All right, without any further ado, let's take a look at the objectives. Here we see in part 1 is configure layer 3 switching. Part 2, configure inter VLAN routing. And part 3, configure IPv6 inter VLAN routing. All right, so what is an MLS, right? So a little bit of the background. A multi-layer switch like a Cisco Catalyst 3650 is capable of both layer 2 switching and layer 3 routing. One of the advantages of using a multi-layer switch is this dual functionality. Benefit for a small to medium-sized company would be the ability to purchase a single multi-layer switch instead of separate switching and routing network devices. Some of their capabilities of a multi-layer switch include the ability to route from one VLAN to another using multiple switch virtual interfaces or SVIs, as well as the ability to convert a layer 2 switch port to a layer 3 interface. Alright, so let's see our instructions. Here is part 1, configure layer 3 switching. So in part 1, you will configure the gigabit Ethernet 0/2 port on switch MLS as a routed port and verify that you can ping another layer 3 address. Alright, so step A on MLS, configure gigabit 0/2 as a routed port and assign an IP address according to the addressing table. Alright, so let's go over to our lab here. Select our MLS switch. It's already powered on, so we are prompted to the CLI or the command line interface. Let's click enter. There we go, and we are in user exec mode. Let's escalate to privileged exec mode by entering the enable command, and then let's do configure terminal command to enter the global configuration mode. There we go. And in this case, we need to configure the interface gigabit 0/2. So let's go to that interface, gigabit 0/2. And we will be converting this from a layer 2 switch port to a routing port. So we will need to put the no switch port command. And then we need to give it an IP address. In this case, IP address 209.165.200.225. Subnet mask is 255.255.255.252. Here we go. All right, so now let's end this interface and let's ping the cloud at this given IP address here. So let's just copy and paste and see if we are able to get responses. All right, so let's click enter. All right, so we have an 80% success rate. That is because the ARPed initial request. And now let's ping again to get 100%. There we go. All right, perfect. So now let's go to part 2, configure inter VLAN routing. All right, so step 1, add VLANs. Add VLANs to MLS according to the table below. Packet tracer scoring is case sensitive. All right, so type the names exactly as shown. All right, emphasis on case sensitive, so we need to make sure that the naming convention is typed exactly as listed. So let's go ahead and configure those VLANs. So again, let's go back to config terminal, global configuration mode. And the command to create VLANs is simply VLAN. Simple as that. And let's give this the ID of VLAN 10. And then the name would be, the command is name, and then the staff for the naming convention is capital S. There we have it. Now let's create VLAN 20. Name is student with capital S. And then the last VLAN will be VLAN 30. and the name is faculty, capital F, faculty. There we go. Perfect. All right, so now let's move on to step 2. Let's configure SVIs on the MLS. Configure and activate the SVI interfaces for VLANs 10, 20, 30, and 99 according to the addressing table. The configuration for VLAN 10 is shown below as an example. All right, so in this case, let's go ahead and configure that VLAN 10 and its corresponding IP address. So let's exit this interface. And let's go back to global configuration mode, and now let's go to interface. In this case, we want to interface with VLAN 10, and let's give that IP address of 192.168.10.254. Subnet mask is /24, or in this case 255.255.255.0. All right, good. Now let's go to step 3. Oh, in this case, let's go back. We need to configure the other VLANs, 20, 30, and 99. All right, so let's go back to the addressing table and let's see at the IP addresses. So in this case, this will be for VLAN 20. Let's go ahead and create that. Exit this interface and let's go to interface VLAN 20. IP address, and then paste it. Make sure we don't have any typos, and its subnet mask is /24. In this case 255.255.255.0. Now exit this interface and let's go to interface VLAN 30 for the next one. Let's copy over the IP address and then give it the IP address, command of IP address, paste the given IP address, and again its subnet mask is /24, so that'll be 255.255.255.0. And then the last VLAN will be VLAN 99. So let's go ahead and copy the IP address, exit this VLAN interface, and let's go enter interface VLAN 99. IP address, paste it, and again it's same subnet mask is /24. So in this case 255.255.255.0. Perfect. All right, so we have all VLANs configured and assigned their corresponding IPv4 addresses. All right, so step 3 now, configure trunking on MLS. Trunk configuration differs slightly on a layer 3 switch. On the layer 3 switch, the trunking interface needs to be encapsulated with the .1q protocol. However, it is not necessary to specify VLAN numbers as it is when working with a router and sub interfaces. All right, so we need to go to the MLS. We are already here, so let's exit this VLAN interface, back to global configuration mode, and let's configure gigabit Ethernet 0/ as a trunking port. So in this case, let's go ahead and enter that given interface, gigabit 0/1, and the command will simply be switchport mode, and in this case we need to give it a trunk mode command. There we have it. And then we need to specify VLAN or assign VLAN 99 as the native VLAN. So let's go and do that by simply doing switchport trunk native VLAN. In this case, we're assigning VLAN 99 as the native VLAN. And we need to do the switchport trunk encapsulation .1q command. All right, perfect. So now let's go on to step 4, trunking on switch 1. So configure interface gigabit 0/1 on switch 1 as a static trunk, and then we need to also configure the native VLAN on the trunk. So now let's go and close this out, and let's go over to our switch 1. It's already powered on. We are prompt again to the CLI, the command line interface. Let's enter, enable, and then config T. Config T. There we go. Now, and we can see here we already are getting those mismatch or VLAN mismatch messages indicating MLS is on VLAN 99 as a native, and currently switch 1 is by default on VLAN 1. So we need to make sure that we switched it from the default VLAN 1 and make VLAN 99 our native VLAN. So how do we do that? Let's go ahead and enter our interface. So let's go to gigabit interface 0/1, And again, give it a switchport mode trunk command. And then we need to do the switchport trunk native mode or native VLAN. And in this case, we're allocating VLAN 99 as the native VLAN. And there we have it. All right, so let's see here. Moving on to step 5, enabled routing. So let's close out our switch 1 and use the show IP route command. Are there any active routes? So let's see here. So since this is routes we're looking at, it should be on the MLS. Given that it's a multi-layer switch at layer 3 for IP routing, we wouldn't see the routes on switch 1 at layer 2. So in this case, let's end from this interface and let's enter the show IP route command. All right, and we can see ICMP redirect cache is empty. All right, so let's close this out and let's move over. Enter the IP routing command to enable routing in global configuration mode on the MLS. All right, so let's go ahead and do that. MLS, we need to escalate to the global configuration mode. Let's enter enable and then again config T. And simply input IP routing command. And there we have it. So let's take a look. Let's do again a do show IP route command. And now we can see the routes that are currently connected. It's indicating C, which is for connected. These are connected directly to that switch or MLS. So we can see we have VLAN 10, 20, 30, and 99, along with this gigabit Ethernet 04/2 interface. All right, perfect. So now let's go over to step 6, verified end-to-end connectivity. We start with PC 0. So let's go ahead and go over to PC 0 and open the command prompt. And we need to ping over to PC 3. So let's do ping command and then what's PC 3's IP address? Let's take a look here. Here we have it. So simply copy that IP address. Let's paste it and then do a ping. All right, perfect. So it is confirmed. We are getting echo responses indicating we do have connectivity. Let's see what's next. So now we have to go to PC 1 over and ping to PC 4. Again, let's go to the command prompt and ping PC 4. What's the IP? Here it is. So let's just copy, paste it, and do the ping. There we go. We are getting echo responses. All right. So then the next device is, let's see here, PC 2. And let's ping over to PC 5. Again, let's open the command prompt, do a ping, and let's get the IP address for PC 5. Here it is. Copy, paste, ping, ping, ping. There we go. So we are getting responses, again confirming connectivity. And let's take a look. What's the next device? All right. So from switch 1, ping switch 2 and 3 or MLS to verify connectivity with VLAN 99. So switch 1. Let's just do the ping switch 2 and 3. Although we have an option to either ping MLS directly just to verify connectivity with VLAN 99. All right, so let's get switch 2 IP address listed here in the addressing table. So again, let's do a ping. This might not work because we're in, let's see. Yep. So let's do a do ping and then I'll try again. This time it should work. And there we go. Since we are in global configuration mode, anytime we do a command, we need to do a prefix of do and then the command. So we have a success rate of 60% again because of the ARP or the initial ARP request. If we ping again, it should indicate 100%. So let's do that. There we go. And correct, 100% success. Now let's go ahead and ping over switch 3. Again, let's do the do ping command. Switch 3. And let's see here. Success 60% again for the initial ARP request. Now let's do again. It should be 100. Perfect. All right, let's see what's next. Alright, so to verify inter-VLAN routing, ping devices outside the sender's VLAN. From any device, ping this address inside the cloud. So let's see, are we able to reach the cloud? We are already on the switch 1, so let's just stay there. And let's do a simple ping command. So do ping, and let's see if we're able to reach the cloud from switch 1. Alright, so we are confirmed. We are able to reach the cloud, switch 1 to the MLS and then to the cloud. Alright, so now let's move on to part 3. We've already configured IPv4 and their corresponding IP VLANs and IPv4 addresses. Now we're moving on to IPv6. So it looks like this might be a dual stack, right? Dual stack in IPv4 and IPv6. Alright, so part 3 is configure IPv6 inter-VLAN routing. Layer 3 switches also route between IPv6 networks. Alright, so step 1, enable IPv6 routing. Enter the IPv6 Unicast routing command to enable IPv6 routing in global configuration mode. Alright, so let's go to our MLS. And this command is very important because even if you have your IPv6 addresses configured to their corresponding VLANs on an MLS switch, if you don't have this command, the switch will not route any IPv6 packets. So let's make sure that we put that in there. Alright, so let's move on to step 2. Configure SVIs for IPv6 on the MLS. Alright, so configure IPv6 addressing on SVI for VLANs 10, 20, and 30 according to the addressing table. The configuration for VLAN 10 is shown below. Alright, so since we're already here, we can go ahead and do that. So interface VLAN 10. And the corresponding IPv6 address. Let's copy it and paste to make sure we get that correct. And we need to do the same configuration over to VLANs 20, 30. So let's go to our addressing table and let's get IPv6 for VLAN 20. Here it is. So let's copy that over. Exit this interface VLAN 10 and let's enter interface VLAN 20 and let's give it the IPv6 address. Paste it over. Exit this VLAN. And let's enter interface VLAN 30. We need to get that IPv6 now. And let's assign it over to VLAN 30 by inputting the IPv6 address command with the corresponding address here. And there we have it. Alright, let's see what's next. So we completed this one. We've verified connectivity. Alright, so step 3, configure gigabit 0/2 with IPv6 on the MLS. Alright, so let's go ahead and do that. Configure IPv6 addressing on gigabit Ethernet port 0/2. So let's exit this interface from VLAN 30 and let's enter interface gigabit Ethernet 0/2. And let's give it the IP address here listed. Should be this one here. So let's go ahead and paste it. All right. So that's completed. Now let's see, use the show IPv6 route command to verify IPv6 connected networks. All right, so let's do that. Exit here and let's do we can just zoom in. Take us back to user exec mode and let's input the show IPv6 route. Okay, and there we have it. We see the routes that are currently connected. S would be for static. Then we see the C's are for connected. And then we see the L's, which are local. And it looks like we've completed the task. And the last step will be step 4, verified IPv6 connectivity. So let's just pick one of these last devices. So from PC3, ping the address inside cloud. So now we have to verify IPv6. And earlier we did IPv4. So now let's do IPv6. So from PC3, again, let's go open the command prompt and do the ping. So let's ping over the cloud. And here we go. Let's see, here we have connectivity. Okay, so we are connected. Again, the first request timeout is simply the ARPed request. We do another ping, it should be 100%. And there we go. Perfect. So it looks like we've completed this activity. Let's check the results. And everything's checked green. Check, 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 checked. All right, good to go. All right, so this completes this Packet Tracer Lab. Once again, thanks for joining me. I just want to point out that it's very essential and an integral part in pursuing your CCNA to ensure that you practice on these labs. It's scenarios in real world configuration. So again, it is very important that we practice on the labs in the pursuit of acquiring the CCNA certification. So thanks everyone for joining me today. And again, I appreciate it. Hope everyone has a great day, and I'll see you for the next video.